Hello students, today we are going to see about the first unit in dynamic submissions, that is force analysis. So we have two different types of force analysis. The first one is static force analysis, which states that when the inertia effect due to the mass of the machine components are neglected in the analysis of the mechanism. In dynamic force analysis, when the inertia forces are considered in the analysis of the mechanism. So what is inertia force? A force equal in magnitude but opposite in direction and collinear with the impressed force producing the acceleration is known as inertia force. Inertia force is equal to minus m into a, mass into acceleration. Next one is inertia torque. The inertia torque is an imaginary torque which, when applied upon the rigid body, brings it in equilibrium position. It is equal to the accelerating couple in magnitude but opposite in direction. Inertia torque is equal to minus I into alpha. Next is D'Alembert's principle. D'Alembert's principle states that the resultant force acting on a body together with the reversed effective force or inertia force are in equilibrium. That is, total forces should be equal to 0. Sigma F is equal to 0. Next is the dynamic analysis for reciprocating engines. The velocity and acceleration of the reciprocating parts of a steam engine or IC engine may be determined by graphical method or analytical method. The velocity and acceleration by graphical method may be determined by one of the following constructions. First one is Klein's construction, second one is Ritterhoff's construction, and the third is Bennett's construction. So, the dynamic analysis in reciprocating engines by analytical method consider the motion of the crank and connecting rod of a reciprocating steam engine. This is the piston point P dash and P, and this is the connecting rod, this is the crank, this is the circle of rotation. This point is IDC and this is ODC, inner dead center and outer dead center. Let OC be the crank and PC be the connecting rod. The crank rotates with the angular velocity of radians per second and the crank turns through an angle theta from the inner dead center, which is briefly written as IDC. Let h be the displacement of the reciprocating body P from IDC after time t seconds, during which the crank has turned through an angle of theta. Let L be the length of connecting rod between the centers, R be the radius of the crank or crank pin circle, theta be the inclination of crank to the line of stroke TO, and N is the ratio of length of connecting rod to the radius of crank L by R. So the velocity of the piston is given from the figure as R into 1 minus cos theta plus N into 1 minus cos phi. For triangles, it is given as cos theta is equal to cos phi into 1 minus sin square phi, the whole power 1 by 2 is equal to 1 minus sin square theta by n square, the whole power 1 by 2. Substituting the values in the equation, we get Vp is equal to omega into r into sin theta plus sin 2 theta divided by 2n. Next is to find the acceleration of the piston acceleration of the piston is equal to omega into r into cos theta plus cos 2 theta divided by n into omega, which is omega square into r the cos theta plus cos 2 theta divided by n. So, when the crank is at IDC inner dead center, take theta as 0. Therefore, the acceleration of the pistons becomes omega square r into cos 01 plus cos 01 by n. When the theta is 180 degree, that is ODC, substitute the value cos 180 degree minus 1 omega square r into cos 2 into 180 degree is plus 1 divided by n. As the direction of motion is reversed at the ODC, changing of sign gives AP is equal to omega square r into 1 minus 1 by n. So, next is the forces on the reciprocating parts of a engine. First one is the piston effort. It is the net force acting on the piston or the crosshead pin along the line of stroke. It is denoted by Ft. Fv is the piston effort or piston force. To find Fp, we have formula net load on the piston plus or minus the inertia force. This is the formula to find Fp. Next is if P is the net pressure on the stream of gas, the diameter of the piston, the net load on the piston Fl becomes P into A, that is pressure into area, equal to P into pi by 4 d square. For vertical engine, the piston force Fp becomes Fl plus or minus Fi plus or minus Wr minus Rf, which is the resistance force. Next one, the forces acting along the connecting rod Fq. Fq equal to Fp piston effort divided by cos phi. We know the value of cos phi as root of 1 minus sin square theta divided by n square. Fq is equal to Fp divided by substituting this value 1 minus sin square theta by n square. The third one is Fn, that is the thrust on the sides of the cylinder walls or the normal reaction on the guide bars. Fn is equal to Fq sin phi. Substituting the value of Fq, Fp by cos phi, or we get Fp sin by cos tan phi. Next is the crank pin effort Ft. Ft is equal to Fb into sin theta plus phi divided by cos phi. Next is the thrust on crankshaft bearing. Fb is equal to Fp by cos phi into cos theta plus phi. Next is the crank effort or the turning moment or torque on the crankshaft. The product of the crank pin effort and the crank pin radius is known as crank effect or the turning moment or torque on the crankshaft. T is equal to F into R. The turning moment diagram is the graphical representation of the turning moment or crank effort to various positions of the crank. It is plotted on Cartesian coordinates in which the turning moment is taken as the ordinate and crank angle as the abscissa. So this is the turning moment diagram for the single cylinder engine, where Fp is the piston effort, R is the radius of crank, N is the ratio of connecting rod length to the radius of crank, and theta is the angle turned by crank from IDC. This is the turning moment diagram for multi-cylinder engine. This is the turning moment diagram for IC engine, which has 4 stroke, suction stroke, compression stroke, working stroke and exhaust stroke. Next is the fluctuation of energy. The variations of energy above and below the mean resisting torque line is called as fluctuation of energy. The difference between the maximum and the minimum energy is known as maximum fluctuation of energy. E is equal to maximum energy minus minimum energy. Coefficient of fluctuation of energy is represented by CE, maximum fluctuation of energy divided by work done per cycle. So to find work done per cycle, T mean into theta is the formula. T mean is the mean torque, theta is the angle turned in radians for one revolution. T mean is equal to P by omega, where P is the power transmitted and N is the speed in RPM. The work done per cycle can be also found out using formula P into 60 divided by small n, where n is the number of working strokes per minute. N equal to capital N for 2 stroke and steam engines, and small n equal to capital N by 2 for 4 stroke engines. Next is the flywheel. Flywheel is used in machines which serves as a reservoir to store energy during the period and supply the energy when it is required, when the requirement of the energy is more than the supply. Coefficient of fluctuation of speed Cs is found out to be 2 into capital N1 minus N2 divided by N1 plus N2, which is the ratio of maximum fluctuation of speed to the mean speed. Energy stored in a flywheel formula E equal to m k square omega square Cs or m v square Cs, where V is equal to k square into omega square. M is the mass of flywheel, k is the radius of gyration, omega is the angular speed in radian per second square, Cs is the coefficient of fluctuation of speed, and V is the mean linear velocity. Tensile stress or hoop stress can be found out using formula rho v square. Rho is the density, n is the speed, v is the linear velocity. You can find out using the formula dn divided by 60. Mass of the rim m formula, volume into density, and for rectangular then the area becomes b into t, where b is the width of the rim and t is the thickness of the rim. So flywheels in punching press is used to perform the function when the torque is constant and the load varies during the cycle. The dynamics of cam follower mechanism can be developed using the rigid body cam system or the elastic body cam system. Rigid body cam system, the members of the cam are fairly rigid, but in elastic cam system the members are elastic, so it is called as elastic cam system. Thank you.